Hi, hello everyone. Nice to be here. So today I'm going to talk about how to enhance your React with advanced TypeScript. We're going to talk about, first of all, should you even use advanced TypeScript types and what some of those types are. We're going to look at discriminated unions. We're going to look at mapped types. And we're also going to sum up a little bit with some conclusions. So should you even use advanced types at all in TypeScript? I feel like the pendulum sometimes swings between people liking something and then starting to hate on it. For a lot of time, people used to love TypeScript a lot. There are fanboys, including myself, who advertised it and said, the more TypeScript, the better. I feel like there's been sort of a backlash against that. People say that TypeScript has gotten overly complicated and they can't understand what's going on anymore. And I usually say that you shouldn't trust influencers, especially if their views tend to be very simple. Things are always more nuanced and more complicated. There's an old saying that experts usually answer with "it depends." Unfortunately, that's not something you usually get a lot of on the internet these days. So should you use complicated types, and should you try to represent everything in the type system? Well, it depends, first of all, on what you exactly mean by complicated types. When you start out, everything tends to be complicated, especially if you come from a JavaScript background where types didn't were not something that you were used to thinking about. So, before you make a decision, make sure you have enough experience with the type systems to actually make an educated judgment about how complicated you want to get. And in the meantime, here are some guidelines that you could follow. So for example, if you're trying to do something, first of all, make sure you're using a pattern that is well documented. For example, one such pattern would be discriminated unions. Now, I think people should kind of already be familiar with unions. I'm hoping everyone here is, because they're a staple of the TypeScript programming. You can't really do anything without having seen a union in TypeScript. Now, discriminated unions might be something you haven't heard of. They make a discriminated union is a union of objects usually that has a field that can uniquely select one constituent of the union, and that field is usually of a literal type. And let's actually see some of this in action and see how discriminated unions can improve a very basic example. So let's say we have a component, we'll call it a selectable list, that takes these props, right? And we can see here that this component supports both single selection and multiple selection. And we can see that we have these two properties which kind of put together options from both the single and the multiple selection. We can see that the onSelect can either receive a string or an undefined if we're in the single selection case, or it can receive a string array if we're in the multiple selection case. And for value, we see here that every possibility is kind of smushed together. We can see string or undefined as being the one for single selection and string array for the multiple. Now, the problem with this approach is that, well, if we look here, we can see that for the cases that should work, they do work as expected. But we can see here that we sometimes mix up single selection with multiple selection value, and multiple selection component type with a single selection. So this isn't exactly great. Now, inside the function, inside the component, it gets even worse. For example, onSelect, since it's a union of function, ends up kind of being uncallable. TypeScript doesn't says, well, if you have two functions and I don't know which one you actually have, I'm going to make you call the function with something that can satisfy both possibilities. In this case, this would mean that the first parameter would have to be string and string array, which is obviously a nonsense type. If you try to pass in an array, well, that's not a string, so that's not valid. If you try to pass in a string, well, that's not an array, so that's not valid. And we'd like to improve this. Ideally, once we've done the checking for the type, we'd like to flow the information to these other variables as well. So the way we can do that is using a discriminated union. So how are we going to do that? Well, we're going to take the same type and we're going to duplicate it, and then we're going to specialize each one of these. So for example, for the single type, we're going to say that onSelect is a function that only takes string or undefined, and the value is string or undefined. And for the second one, we're going to say that the type has to be multiple, and then we can delete the options that are specific to the single selection case, the types from the unions. And now the first thing we can see here is that we now get errors when we sort of mixed and we weren't using this component properly, right? Here where we said type is single selection and we're trying to pass in an array, we now get an error. And we can now get an error. So this is already an improvement in how people would use this component. Now inside this function, we notice something interesting happens, right? We took this list prop type and this list prop parameter and we destructured it, and we can see here that once we have checked the type, right, we can see that on select here now is no longer has that type where the value has to be string and string array. We can see that TypeScript has narrowed the type based on the check we did on the on this type parameter, right? And TypeScript is able to follow the fact that we had here a discriminated union, and when we destructured out of that union, these variables kind of remain in an entangled state, and when we check one, we basically narrow the others as well, right? And we can see here this type property is the discriminant, right? It has this literal type, and checking it will uniquely determine one constituent of this union, right? Then we can see that also that same thing also happens for value. On this branch is going to be string or undefined, and on this other branch where the multiple selection case case is going to be a string array. So that's pretty neat, I think. It's an improvement you can do. Is that very complicated? I don't think it is once you're familiar with the pattern, and if people are familiar with it, they will understand what you're trying to do there. I just want to point out that both objects and tuples can be discriminated. So, for example, if we were to look at another example here, we can see that we have this hook that gets some data, and it returns a tuple. Now, a tuple is just an array where the items can be of different types, and we know the types of each item in the array. So, for example, here the first item is either error or undefined, and the second item in our tuple is going to be either the response or undefined. And here where we're trying to use it, we again notice that we have an error, one that we probably don't actually want. Because if we're checking that if error is undefined, well, if error is undefined, that means we didn't have an error. So that means that we should have a piece of data there that we could access. But at the moment, the way we wrote our types, TypeScript can't actually follow that. Why is that? Well, with this type, nothing stops us from returning something that is undefined, an array with two undefined in it, right? But we don't actually do that, right? We know that if we have the error, then the second element will be undefined, or if the error is going to be undefined, then the second element is going to be that piece of data that we are returning. So what can we do here? Well, we can, again, create a union, right, where we can be more explicit about the relationship between these two items. So if we're returning an error in the first item of the tuple, then the second one is always going to be undefined. And on the other case, if the error is going to be undefined, if the first element is going to be undefined, then the second element is going to be an API response. And we can see that, again, TypeScript kind of magically manages to figure out the types now, right? We took the tuple and we destructured it here, and we checked the error property, and then the data property will get narrowed, and TypeScript will know that this is no longer undefined if we checked for error being null. While on the else branch, we can see that if we hover over data, it's going to be undefined because, well, now we have an error, so obviously data has to be undefined, right? And in this case, basically the first item of this tuple acted as a discriminant, right? Because even though it wasn't a literal type in both cases, right? It is a literal type in the undefined case. Undefined is a kind of literal type, right? As long as we're able to narrow most of the all of the other options and we're only left with one other option, that is still close enough for TypeScript to be able to understand that this is a discriminated union. So, well-documented patterns really help. But the second thing I think we should kind of always take into account when we're trying to use more complex type is it worth the extra complexity to actually use them? And usually that is the case when we want to improve developer experience in, for example, the call side. This usually makes sense when we're going to have code that ends up being reused a lot. So one prime example of where you want to consider this, if you want to add the extra complexity, is using generics, right? Generics can be either type generics or function generics. We're going to talk about generic functions right now. And a function can have type parameters. They're introduced with these angle brackets right after the function name. And once you've defined that type parameter, you can use it anywhere inside the function. For example, we can use it as the parameter type here. Now, generics are usually useful for capturing information from the call side, right? So, for example, when I call this function with a number, then t is going to be inferred as number. And the point of generics is usually, and of type parameters, is usually to tie together. You're either tying together parameter types. So, for example, here we could have two parameters, and we establish that if the first parameter is t or undefined, then the second parameter will have to be t, right? We don't know what that t is. We don't really care, but we know that that is the relationship that has to be there. So now when we're calling a function, we're calling our get value function, if we're passing in the first parameter as being number or undefined, then if the second parameter is also a number, then that is fine. But if the second parameter is a string, we're going to get an error because the types don't match. And the same is also true. We can also tie together some parameter types to the return type, right? So here we added this explicit return type of t. And that means that we've established the relationship now again between parameters and return type. And if we call this function, now it's going to return a number because, again, this generic parameter will flow the information from parameters to return type. So let's take a look at how we could use this to improve something in one of our projects, right? And let's say we have a hook. I called it use modal, and let's see how we actually use this hook. So we call use modal, and we give it a component, right? And this component has a callback on close that is going to call with the result of this modal dialog box, right? It's going to be and the result can be yes or no, right? And then this hook will return a function that we can call, and then we can wait for this modal to be dismissed, and we want to get the result type. Now, the problem right now is that this promise that we have here is a promise of unknown, right? Even though the modal we're passing in will return yes or no, the information doesn't flow from our component to our open function. So here, when we actually get this result, the result is going to be unknown, and we're comparing it with OK, even though our function is returning yes or no. So that's obviously a problem there. So how can we make sure that we flow this information from our question component to our to the open function that is returned? Well, we're going to need a type parameter, and we're going to introduce it there in the use modal hook. And now we can use it anywhere inside the function. So, for example, we can use it here in the type of the component parameter, right? And we can say that our component has to be a component type that has an on-close property with and the parameter for that callback is going to be something that is of type t. Now, we already see here in use modal that TypeScript already captures this information, right? T has now is going to be this yes or no union because that is the kind of component we passed in. But just defining this doesn't help us much unless we also use it somewhere else, right? We captured the information, and now we have to make sure it gets all the way to this open function. So let's see how we can do that. Well, we should try to add this the type parameter anywhere where it makes sense, right? So for example, here I have a state that sort of represents the will hold the resolver for the promise. So the resolver should have their a type T in that callback because that's what we're returning. This on close should also be of type T. And here this promise, which was previously not specified, we didn't specify any type. We should also specify that we're returning a promise of type T. So what happens now? Well, now this information is going to flow from our use modal hook, right? We see here that T is the union yes or no, and that is now flowed to this open function here that now returns a promise of yes and no. So now when we're calling it, we can see that the result here is also has the type information from our dialog component, right? It's yes or no. So now we can see that, okay, we got an error here because we're comparing something that is never a possibility. We should probably have been comparing with yes. So you have to make sure that using generics is worth the extra complexity. But I also want to point something. I think another rule that is very important when you're trying to use more complicated things is that you should try to make sure that the code you're writing can be understood by others. We as developers spend a lot of time actually reading code rather than writing it. If you're going to use a lot of complicated map types and conditional types, those are often hard to understand, usually even for the person that wrote them. I myself have written very complicated type things which I thought were very smart, and I was very happy with what I did there. And I come 6 months back 6 months later, I come back to them and I look at them and I say, I don't understand how any of this works anymore. That's even worse if you're working in a team that other people have to look at that code and have to understand it and have to actually be able to modify it and maybe maintain it after you've moved on from that project. So if you're using these nested and conditional types are often hard to understand. The worst part is they're often also hard to debug. There's no built-in debugger for types. And what we usually end up doing is just hovering over types and seeing if they return the type we're expecting. We maybe sometimes split them out and again hover over to see if that worked or if the type is what we expect. So they're usually pretty difficult to debug. So, if you're thinking of doing something more complicated, the best thing is, first of all, to prefer the built-in mapped and conditional types wherever that is possible. And there are lots of types that can help you with that. For example, there's type to change modifiers, there's type to manipulate properties and extract types from other types. And let's look at an example of how close that can get us to something that we want, how close the built-in ones can get us. So right now we have this use form hook, right? And we can see that we're using any in some of these places, right? And the basic idea of this hook is that we give it a piece of data. We also give it a function that should be called when that data changes. And we also have an object that will validate and convert the values, right? We get the value from the input, it has to be validated, and then the function also has to return the value that should end up in the actual data object. So we can see here that we're doing this work now, right? We are calling use form, and we're passing it an user and a set user, and then here we're passing it an object that should have the same properties as user. The problem is that right now it doesn't. This username is obviously misspelled, and unfortunately TypeScript doesn't warn us about this. So how can we add extra type information here? Well, the first thing, as with the previous example, is that we need some generics, right? Because we need to capture the information from the call site to know exactly what kind of object we're editing, right? So, and that's, first of all, we're going to say that data is of type T, and set data also has to accept something that is of T, right? And this will ensure that we're passing in the correct pair of user and set user. But now let's go to this third parameter, right? Right now it's a record of string and this function type, and that's all, pretty good. At least we can't we all the properties in this object have to be functions, right? We can't just pass in something else that is, for example, a string. That's not valid because it's not of a function type. But as long as it's a function type with the appropriate signature, any properties can be in there because we said that it's a record of string, right? Basically, this is an object with any properties in it. Now, what we can do here is we can actually say that it's not a record with any kind of properties. We can say that it's a record that only has the keys of whatever type we passed in. In this case, this generic type parameter t. And we can see now that TypeScript has correctly detected that, oh, your username, this is not a property that exists on T, so it's not valid here. So we can correct this error. We can also see here that the errors object right now is also something that has string in it, right? It's a record of string. This means that we can basically have any property, we can access any property in there, right? So if we were to have misspelled this again here when we were displaying the errors, TypeScript would not have given us any sort of feedback. So what can we do? Well, we can say that the errors here, right, where we had previously a record of string and string, we can say that no, the keys should always be the same keys as our original type T. And now we can see that we get an error here, and we also get code completions, and this is already a pretty good experience, right? Just using the built-in mapped types, and record is one example of such a mapped type. Now, there's still a problem here, right? When we return in this validate and convert function, we can see that, for example, so we can see that the expected behavior of these functions is that they should return the new value for that property, and this value should ideally be of the same type as the type was in the original object, right? So this age function should return a number. This username function here should return a string because that is the property type in the original user type. So how can we get closer to that? Well, one option would be here, instead of any, to say that we return t key of t. And this basically means that t key of t is going to be is going to be a union of all of the value types inside this inside the original type. So for example, for user, it's going to be string or number. And this is already an improvement. We get an error here saying that age must return string or number. So for it can no longer return void. So if we say here return v, TypeScript is again happy with us. We can, for example, return true because true is a Boolean, and that is not one of the possibilities in this object type. Unfortunately, there is still no relationship between the property name here and the return type, right? For example, first name is returning a number even though the original type was string. And even from age, we can also return a string even though the property age was supposed to be number. And this is the moment when we should probably drop down to a custom mapped type. And in order to do that, let's first of all look at what a map type looks like. So map type basically is a vehicle for us to iterate over a union of keys. They're often paired with key of to get the keys of an existing object type. So we can see here that this mapped type here iterates over the keys of an existing type O. And we can also change the type of each property. And we often use the indexing operator to get the type of the original property. So for example, here we're saying that the property P has the type O of P, right? Which basically means the same type as the original property. So how does this work? Well, TypeScript is going to go through each one of these keys, and then P, that type parameter there, is going to be in turn each of the keys of the O type. So first P is going to be first name, O of first name is going to be a string, and that's going to be the resulting type the type for first property in the resulting type. Same for student. O of student is going to be Boolean. That's going to be the type in the resulting type, and the same for age, right? We look up the type of age in the original type, right? So this is basically an identity mapping type. It doesn't actually do anything interesting. But let's go back to our demo and see how we can actually use it here, right? So I'm going to comment our record version for a second. And we're going to have a custom type here, right? We're going to go p in key of whatever type we got. And like I said, if we were to just pass here t of p, then the type of each property would have to be the same as the original, right? In this case, age would have to be number, right? And we get an error saying that, well, I can't pass in this function to a number because age should be a number. But the point is we can change the type here and we can use any type we want. So we can say that instead of just being t of p, we can say that it's a function that accepts a string and returns whatever the original type was in the type that was passed in. So what happens now? Well, we can see that we get some new errors, right? We can see here that age is now supposed to be a function that returns a number, right? We can see that TypeScript says that a function that returns a string is not a function assignable to the function that should be returning a number, right? So we can fix this error here. And also for first name, now TypeScript will warn us that, oh, you are returning a number there when you probably should be returning a string. So, using this particular map type, we managed to establish a more clear relationship between the property types and what we expect in this validators and converters object. So, was that example overly complicated? Well, not if you know the syntax. The problems usually come up when you layer such types one on top of the other. Map types on top of other complex types, or conditional types on top of other complex types. That's when you sort of tend to run into trouble. What kinds of problems? Well, readability and maintainability, which is something I already mentioned, but also compiler performance. Your builds will be slower because TypeScript needs to evaluate all of these, and usually that is something that is pretty expensive. And something that you might care about, also IDE performance. Your IDE will get slower because of such complicated types, and your colleagues will definitely not thank you if their experience is a lot slower, even if you catch more type errors. So when you're writing some of this, here are some things you probably shouldn't be doing. The first one that I see a lot of people do is obsess over the generic function you're implementing and its type safety. You will notice that I did not even bother, looking too much at this code. You will see that it has a lot of red squigglies. There's a lot TypeScript is not happy with me about in there. I don't care. If I was actually had to finish this implementation, I would probably assert some of these to any, because that is not what I'm optimizing for. Complex types and complex generic functions will probably require some assertions in their implementation. What you're optimizing for is the caller developer experience. That is why I said that it's important for these to be functions that are called multiple times for it to actually be worth it, right? So if you're using these for like a function that is going to be invoked once or twice, it's probably not worth the cost. There's also the extreme edition of what you probably shouldn't be doing. Don't create your own class systems in the TypeScript type system. You can do it, but ES already has classes. Why would we be creating a new type system? This might be worth it if you have a legacy type system. Some of us do. And while you're migrating, some of these more advanced techniques might be useful to help you, but that's definitely not the end state. Even if you think that code is very smart, it's probably code that should end up being deleted at some moment in time. Don't parse other languages in the type system. It'll probably make your compiler a lot slower, and it'll probably generate errors that are very difficult to read. Generally don't depend on the fact that you can actually write fully fledged programs inside the type system. What you probably should be doing is, get more familiar with advanced TypeScript techniques. even if you're not the one writing them, it's still useful to understand them. You might still benefit from understanding other people's code. uh, if you want to use, if you have library code, think about using these more advanced conditional map types. They might help the developer experience. And make sure that your team, the team you're working with, also understands these advanced types and can actually maintain them in the future. Thank you very much. If anybody has any questions.
Thank you so much for your presentation. We have quite a lot questions in Discord, and yeah, let's start answering them. The first question is from Valeria. What are some common challenges developers face when working with advanced TypeScript features in React, and how can they be overcome? You probably partially
I think
answer it, but it makes sense to recap.
Yeah, sure. So I think the performance in the TypeScript compiler is one of the first thing that usually tends to suffer when you use very complicated things. I think sort of errors are also probably the one that's most sort of front facing. The more complicated the types you're using, the more complicated the errors you're going to get. And a lot of the times it's going to be very difficult for you to understand what exactly the problem is. And it's great that TypeScript catches some of these inconsistencies and some of these errors, but if you cannot understand the error and fix them, you might have as well just have run the code and hope that you encounter the error at runtime. So I think that's definitely one of the big problems that is still very often something that people struggle with.
Yeah, makes sense. Thank you. Moving to the next question. Can advanced TypeScript types assist in optimizing component performance, or are they mostly for type safety and predictability?
I don't see necessarily as optimizing runtime performance something that you can rely on types a lot for. Types are definitely something that only exists while you're compiling that code. The runtime has no idea of these types, and a lot of the times you can get into trouble for reasons other than the kinds of properties you're passing in. I think TypeScript does tend to steer you towards patterns that are more performance friendly, mostly because you tend to do less crazy dynamic things when you're using TypeScript, because TypeScript is more rigid and doesn't let you sort of get away with sort of very things that are very dynamic. But ultimately, I don't think it's something that you can actually rely upon. It's mostly for developer experience, for making sure that your code is has less errors rather than for performance.
Yeah, makes sense. Most likely, you don't need to write in defensive state when you are validating every single property, but anyway, it's probably a small piece. Yeah. Thank you. The next one is more provocative, I believe. The problem with generic types of function is that people who use them tend to omit passing the type of for generic part, which results in losing type safety and even to some issues, depending on what's the default value of the generic. Is there any technique to prevent that?
Well, I think sort of that really depends on the kind of generic function you're writing. When people say they omit passing the generic type, people shouldn't be passing the generic type explicitly. I mean, for example, use state is an example of a function that requires you sometimes to specify the generic type. That is usually an anti-pattern, because people, if you're using generic types, generic functions, the type should be inferable from your parameters, right? When people call your function and they pass in some arguments, that is the source where you should be getting the type parameter type from, not from people putting the angle brackets and in on the call site. That is usually not something that should be happening, because at that point, like I said, type parameters are useful for establishing relationships, right? If your type parameter is unused or is used in a single location, what is the relationship you're establishing? What is the relationship between what and what? So that's, in my opinion, usually, if this shouldn't be an issue, because generic functions should be designed in a way that they do not require explicit passing of parameters of parameter types. Sorry.
Thank you. And we have more questions. Keep them coming. What do you think of naming for generic types? I often see them named shortly like T, even in your keynote, but in my code, I prefer to give them meaningful names like form, fill, value, type. What is your preference, actually?
I mean, for simple examples when there's just one type parameter, I think T is good enough. But I definitely agree with you that if you have like more complicated examples where you have two or three type parameters, then giving them more meaningful names is definitely worthwhile. As long as you respect the convention that they should probably start with a capital letter. I'm totally fine with giving more meaningful names. And again, this was just sort of a minimalistic example, so probably if this was a more complicated generic function, I would have also used more explicit naming.
Yeah, thank you. Makes sense. Yeah, but probably in general, the convention is to use just letters like T, K, U, and others in very generic
Yeah, for sure.
case.
There's a lot of that, and that does make it sometimes hard to understand exactly what's going on. So
Mhm.
that can definitely be a problem.
Yeah, especially with complex types, with complex functions. Uh, One more question: what is your favorite TypeScript feature?
I think my favorite TypeScript feature is something that sort of evolves from version to version. I still remember
Mhm.
the dark days of 2 point something when we were all waiting and begging for conditional types because we knew they were right
Mhm.
around the corner, and every question that I answered on Stack Overflow was like, this would be so much simpler if conditional types existed. And then they appeared, and that was my favorite feature for a while. I think sort of the latest thing I showed where TypeScript sort of remembers that some variables are entangled because they came
Mhm.
from a discriminated union. I think that's currently something I really like and I think is really cool. But again, I think that has evolved over time. I think I went through a period where like string manipulation was also interesting in the type system, and I thought that was something I liked. So I guess sort of my answer is not a very satisfying one. It's basically the latest interesting thing that came out is usually what ends up being my favorite feature for a while.
Okay, makes sense. So you mentioned conditional types, but at the same time, they make the typing is much more complex and hard to read. But anyway, they're useful.
For sure. But without them, it's hard to do a lot of the things that you can do in TypeScript.
Mhm.
So I think sort of they're necessary, not necessarily evil, but they are necessary in order to make certain kinds of patterns. But again, that is the kind of thing that you probably want to push back in library code, in something that people are going to use a lot of the time, and you're sure that you can offer good errors, and you've tested those types, and you know that they work as you expect them, not only for checking but also for the developer experience.
Mhm. Thank you. And maybe the last one. Uh, do could you suggest any I don't know, open source libraries that helps write types in TypeScript? On have you used one? I know that there is a hot script library that it's very advanced. It is more like an academic thing, but maybe there are some examples that you would like to suggest.
I i don't I'm afraid that this is not a very satisfying it's not going to be a very satisfying answer. I don't use
Mhm.
these libraries, so I'm not going to recommend them. I usually end up writing these if I have complicated types I want to write. I usually end up writing them from scratch. uh, that is both the fact that I don't want to add a lot of extra dependencies to my project, but also because I find that you know learning a library that is in fashion now might be more restrictive, and if that goes out of fashion, you might lose some of that expertise. Learning the basic syntax is always going to be useful. Also, some of these libraries kind of force you to layer types on top of another to actually get do things, and that is something that TypeScript has limits for. So are they useful? Sure, they can be, but I cannot speak to which one I would recommend because I don't personally use them, so I
Mhm.
don't want to venture anything there.
Okay. Thank you so much. Thank you for a great presentation.